Alright guys, so this is our third and final video for our Flip the Classroom lesson, introducing conic sections with a focus on parabolas. And in this lesson we are going to discuss parabolas as conic sections on the XY axis with vertexes other than the origins. We're talking about vertexes HK in this case, where HK is not 0, 0. So in our last video we said we can define a vertically orientated parabola with its vertex at the origin as x squared equals 4py for a parabola as a conic section on the xy axis. And horizontally, we can define that parabola as a conic section on the xy axis as y squared equals 4px. If we have a vertex at the origin. Now, part of the reason we call this standard form for the parabola as a conic section is we're able to easily identify that p-value within the form of the equation. Remember that p-value, the focal length, is the length that defines the position of the focus and the directrix. And the focus and the directrix are determining the shape of the parabola. Remember that the parabola is going to be all ordered pairs that are equidistant from that focus and the directrix. Right here what we have is a parabola determined by an equation, y equals -1/2 x squared. And this equation is in standard form for a polynomial, right? If we want to convert the form from standard form for a polynomial to standard form for a conic section, the easiest way to do that is to isolate the square. So right here what we're going to do is multiply by -2 on both sides, and that is going to give us x squared equals -2y. Now right here what we can see is that we have that coefficient 4p as -2 within the form of our equation. So we can say 4p equals -2, and that gives us a p-value of -1/2. And with that p-value, that focal length, we can define the position of the focus and the directrix. We know that the p-value of -1/2 is going to be the distance from the vertex to the focus. So that gives us a focus of 0, -1/2. And we know that since the vertex is halfway between the focus and the directrix, we can travel that same focal length of 1/2 in the opposite direction to get the horizontal line y equals 1/2 as our directrix. Now right here what we want to do is take a look at a rigid transformation of our equation y equals -1/2 x squared. And over here we have y equals -1/2 x plus 2 squared plus 4. And this is the rigid transformation that takes our parabola 2 units to the left and up 4, giving us a vertex of -2, 4. Now, right here, what we're saying with the rigid transformation is that basically the shape is going to be the same. The only thing that's changed about our parabola in this case is the position of the parabola on the xy axis. And what that means is that p-value of -1/2 is still going to define the position of the focus and the directrix from the vertex, right? So right here, with a p-value of -1/2, we're basically saying that our focus is going to be down 1/2 from our vertex, and our directrix is going to be 1/2 in the opposite direction, moving us up 1/2 to give us that horizontal line. And here we have the focus and the directrix that define the parabola with the vertex -2, 4. Now, if we want to change the form of our equation from what we might call vertex form here to standard form for the parabola as a conic section, we're going to do the same thing that we did over here. Remember, over here we basically multiplied by -1/2 on both sides and got the square isolated as x squared equals -2y. And we're going to do the same thing for the rigid transformation here. So to get our equation in standard form for a conic section on the xy axis, we're going to isolate the square. And basically what that's going to mean is subtracting 4 from both sides and multiplying by a -2. Now that's going to give us right here x plus 2 squared equals negative 2 times y minus 4. And what we're seeing right here is that same 4 p-value of negative 2 determining the p-value that gives us the position of our focus and our directrix from the vertex. And what we have with the form of the equation right here is a parabola that is of the form x minus h squared equals 4p times y minus k, where we have our vertex as hk. And this is standard form for the parabola as a conic section on the xy axis, where that parabola is vertically orientated. So what we're going to do is we're going to take this equation down and start determining our focus, directrix, and focal width generically from our parabola right here. Right here what we have is a parabola on the xy axis with a vertex at, let's say, hk. And what we're going to say is if we are defining our focal length in that exact same way as being the distance from the vertex to the focus point, then we can define the position of the focus with the ordered pair h and then k plus p. Because basically what we've done is gone up the focal length p from the vertex to the focus. Similarly, right here, we can say that we are going p in the negative direction to determine the directrix. So right here, we have y equals k minus p as the horizontal line that defines the directrix. Now, right here, what we're saying is that that focal width is basically going to be defined in that same way. So right here, we're going to be able to say that the focal width is still the width of the parabola through the focus, and it's still going to be defined as the absolute value of 4p. Right here, if we go up to our example, we can basically apply the definitions that we got down in our generic case to our to define our focus and our directrix. So right here, what we can say is that if we go from our vertex and go basically the focal length down negative 1/2, we're going to end up with a focus of negative 2 and then 3.5, which again is going to be h comma k plus p, where p is that negative 1/2. And then right here for the directrix, we have y equals, and then it's going to be the k value of the vertex minus our p value. So 4 minus negative 1/2 is going to be 4.5. And we've defined the position of our directrix right there. So right here, what we're basically seeing is that whether our parabola is orientated vertically going up or vertically going down, we're basically going to be able to use these same definitions in the same way we did in the last video to determine the focus, directrix, and focal width, as well as the equation, right? So if our vertically orientated parabola is opening up, we're going to have a positive p, and if our vertically orientated parabola is opening down, we'll of course have a negative p. If we've got a horizontally orientated parabola with a vertex at hk, we're going to be able to define the equation for this parabola as a conic section on the xy axis as y minus k squared equals 4p times x minus h. And from here, we can say that focal length, still the length of p, is still going to be the distance from the vertex to the focus. So if we want to define the focus as an ordered pair, we can say we're going to be the length p from the vertex to the focus, and that's going to give us basically the focus as the ordered pair h plus p, comma k. The directrix is going to be the vertical line now that is P in the opposite direction, so negative P away from the vertex. And right here we're going to be able to define the directrix as x equals h and then minus P. So right here, that defines the focus and the directrix for a horizontally orientated parabola with vertex hk.